Okay. Hi, everybody. How you doing? Hi. Yeah, SpringOne Tour. It's an event going on today. Good question. So first question, right out of the gate. What is SpringOne Tour Seoul? So that's happening today. Let me see. Darslong.com. Let me share my old screen here. Let me see if I got anything that needs to be not here. Okay, so what do we got? We got this joshlong.com. I've got some code I need to write, friends. That's what we're doing here. I've got some code I need to write, and frankly, I'd rather just write it on the stream and have some people to talk to. So here's this. Is this it? Come on, please work. Yeah, SpringOne Tour Korea. That's happening today, like later today. You can still join us, I think. Just I don't know how to read Korean, but I see a colleague. I know her, so you can message her. Join us. Well, I'm in Korea. I'm in Seoul. If you're here, join us. Right. There you go. Good stuff, huh? Look at that. Look at that. So, hello, Benjamin. Hello, everybody else. Hello. Let's see here. I just realized I'm gonna. You know what I'm gonna do? I'm gonna launch all this stuff on my iPad so I can answer questions over here. Okay, there we go. There we go. Good. Whoa. That was good. Forgot to turn off the volume. Let's see.
Oh, yeah, fun and hot. Oh, very cool. Thank you.
Yeah. Like, Oz is great.
Let me see if I can mute this.
Test. Test, test. No, I don't want that. Computers. Let's see. So you were in Oz. Yeah, I was just in Australia, and Australia was lit, right? Like, okay, cancel, and then join without mic. Test. Okay, now we're cooking. Now I can see the comments and all that without having to see them over here, which is good. So yeah, I'll be here. I'll be going to. This is today's 2 o'clock. You can probably still join us. I don't know where it is. If you speak the Korean language, this is going to be obvious too. For me, it's all Korean, right? I wish I did speak the language though. Yeah. Thanks for that. If you're, I take it Adam here saw me perform at some event in Australia last week. So take it from him. It could be worse. It not much worse, but it could actually be worse. You could actually do a lot worse. Not a lot worse. You could do worse than coming to see the show today. Hi, hello, Spring fellas, and yeah, hi, good to see y'all. Okay, so anyway, here's what I'm trying to do. Okay, and like, just like, where's my sample? Okay, so here's my sample. Right, here's the sample. I've got you've seen the. Oh, here's my example. This feature right here. Right. What I want to do, in order to see this declarative interface, this is a thing inside of Spring Framework 6 and later, and it looks awfully similar and is very similar in spirit to the thing that we had in Spring Cloud OpenVein and Spring Cloud Square retrofit, and in Spring RetroSocket, this this thing I built for RSocket, basically, that Mario and I built. So this is basically, you have a declarative interface and you can use it to create an instance, a bean that actually you can then inject and then use to invoke this method, and it'll actually make a call to this host and this path, right? Passing in this path variable for you. The problem is, in my estimation, if you're just asking me, and it's just between us friends here, I think it's a little verbose. I think it takes a lot of work. Like, in order for that to work, you have to register a bean, and that bean has to look like this. So I can say to-dos, right? And then I'm going to create a web client.builder, builder, var wc equals builder dot. You can specify, I can just build it, right? But you might want to customize it. And then you say HTTP service proxy factory dot web client adapter for client, and then you pass in this, and then build, and then create client, and then to-dos dot class. Okay, and then that works, but it's basically the same code. The only thing that changes from one invocation to another is you might want to customize the web client. And so there's a way to, wouldn't it be great if we could automatically discover the interface and turn it into this for you and just give you that resulting thing automatically? And wouldn't it be great if you could define the web client and you could use a qualifier? You know, Spring has this great qualifier mechanism. So I can say what if I had this, let's say I created my own web client here, web client dot my custom to-dos web client, right? Web client dot builder, turn builder dot base URL, whatever, or let's just say build. So this is the custom specified, you know, I've got my default headers, I've got my default cookies, I've got all this stuff that I care about specifically for my interaction with the to-do service, but I only want that thing to have it, only my to-dos. And so I can use qualifier notations in Spring to say, I want this bean to only be available by the type web client and this qualifier called to-dos. And the nice thing about qualifiers is also you can create your own custom qualifiers. Did you know that? So I can take this annotation and copy and paste, get rid of that. And then this can be called to-dos. And I can just say at qualifier to-dos, right? So I'm going to say to-dos qualifier, because I already have a type called to-dos here. So now I've got my own custom annotation. And if I add that to this, right, now if I want to inject this particular web client, I can go anywhere else in my code and I can inject it. Like here, I can say to-dos qualifier web client, right? So Spring has a way of doing a type safe and, you know, name based binding. You know, I can bind the producer of this web client to a site. So even if I have like 5 different web client beans, only this particular one that has this qualifier notation will get injected into this site here. So that problem's already been solved as well. I don't really need, I could solve the problem of how do I automatically discover the correct web client. So what I want to do is I want to do this automatically, okay? And we did some things like this before. I've done this code before. Actually, this code, I've gotten code like this working before, but I want to try and take a different approach. So if you look at this is the RetroSocket support, right? And this is the, you know, RSocket client builder and auto configuration, and the client factory bean and the registrar. There's a lot of stuff moving. There's a lot of like Spring stuff here. You know, like this is a lot of this is just making the component model as idiomatic and clean and concise as possible. So here's the RSocket client registrar from the RetroSocket project, the now defunct. Don't use this. Because there is better support for this in Spring, right? In the same way that I'm using HTTP for my demo here, there's also an RSocket component model in Spring. So there's no need for this programming model, this whole project, which is great. Like nobody wants to maintain an extra project, but I do wish we had some of the usability of Spring Cloud OpenFane and Spring RetroSocket and Spring Cloud Square retrofit. So today, you know, in my next hour or whatever, before I get, you know, people are going to come collect me at the hotel and we're going to go off to the, you know, whatever, the activities before the show, the big show today. Before that happens, maybe we can spend some time and write some code and see how we can make that work. And what I've done so far, like, so let's just get rid of that for now. We don't need it. And we don't need this here. And let's just let's not worry about the binding of the web client. Right now, I just want to make the first part work, which is given an interface, like, can I write some code in Spring to automatically discover this interface? And then once I've discovered it, to automatically create a bean out of it of, you know, using that HTTP service proxy factory. You with me so far? Everybody on the same page as me? Like, I want to do this automatically. I want it to just do component scanning basically. And so we need to write a little bit of low level stuff, because remember, this to-dos, it's not a Spring bean, right? It doesn't, it's just an interface. In fact, this is optional. So I need some way to discover just this, right? Like just that interface. I cannot rely on this being on the type. I can rely on there being annotations on the type of type HTTP exchange. So for example, get exchange is actually HTTP exchange. But even that's pluggable, right? If I'm doing this for HTTP, that's one thing. But for what is it, destination, for RSocket, it's a different exchange, right? It's not the same type at all. So we need to like, this is HTTP exchange for get. But you know, I need to discover meta annotation. So this is actually this. I need to discover that. And I also need to make this pluggable so that later on when we do the same trick for the RSocket support, that it works. And then to make this even more fun, what I want to do is I want to make it so that this all works in GraalVM, right? So we have a lot of different dimensions of like effort here. And I got this working before, but I just don't like the way it worked before. And so we're going to take a little different, a bit of a different tact this time. Okay, let's delete that. Good. Okay, so where am I so far? Let's catch up so we can kind of understand. So we got rid of this web client, this example here. We don't want that. We don't want a bean that does the work for us. Right now, what I'm trying to do is I'm trying to figure out what is the right interface in which to register a new bean. And I think this one is bean definition registry post processor. This is a subclass of a bean factory post processor. And it gives you a chance to post process the bean definition registry. That is, you get a pointer to this. This in turn is if there's implementations of it of type application context, configuration class post processor. You know, it's a bean registration AOT processor, bean factory initialization AOT processor, application, you know, bean definition registry, all this stuff. It's an application class that gets called before the bean graph has been sort of contributed. So I'm trying to make Spring make an implementation of your interface on the fly right now. Yes, exactly, Benjamin, exactly. So right now, in order to get it to do that, I have to do this. I have to manually create a bean, and I use the framework library, and it's not so bad, right? This is not so bad because there's some options here, right? I can do this like that, right? And so this won't go away. This is still very much, and there's an equivalent. It's not called HTTP Service Factory. It's called RSocket Service Factory, I think. RSocket Service, something like that, right? There's a similar thing for RSocket. And there are some things you need to, you might want to have a custom argument resolver, embedded value resolver, reactive adapter registry, all this stuff you could configure. But for 99% of the cases, all I configure is this web client adapter. And even that, like, if I've only got one web client in the Spring application context, then just use that. Like it's pretty clear to me, just use that one, just inject it by type and be done with it. It shouldn't be so explicit. So what I want is just here's an interface, create the thing for me. And I don't like having to do this. And maybe it's just me, right? I do a lot of demos. I do a lot of presentations on stage. And so I end up typing the same code over and over and over and over and over and over again, which is fine. I love my audiences. I want people to take the same journey with me. And kind of walk through the very beginning and see all the pieces. But wouldn't it be nice if this just worked? Like if you could just define the interface and Spring automatically turned it into a bean, just like with a Spring data repository, an interface-based repository. So yeah, let's try and make it so that we don't need to write that code there, okay? And the first thing is trying to figure out the right lifecycle event. When's the best time to do that? And I think it's within one of these bean definition registry post processors. And to prove it, I'm going to build a cat bean, okay? So here, I've created a bean definition, and it's of type cat, and cat is just a class with a constructor. That's nothing special about it, just a demo, right? And I've created a bean of type cat, and I'm going to register the cat, and then what I also want to do then, so that what I'm doing is I'm programmatically building a bean definition and adding it to the Spring application context very early on. And so in theory, if this works, then the next trick will be to see, okay, does this show up as a regular cat? Can I see it when I sift through all the beans later on to analyze it, right? And also, does this work at compile time? Does this get run early enough at compile time that when I go through the beans in my compile time GraalVM code, I see that there's a bean of type cat, right? What I want is Spring's AOT support for declarative interfaces. I want that to kick in, okay, and automatically register the GraalVM native image hints for that type at compile time. So there's a lot of things here. There's a lot of lifecycle issues here. Yeah, so forget about this for now. We're just trying simple stuff just to prove out the idea, okay? We're just trying to do very simple, okay, can this programmatically register this bean? Remember, I have no component. I'm not using a bean definition. I'm creating a bean definition for type cat, creating the bean definition, and then adding it to the context with the name cat. Okay, that's it. This is me programmatically registering a bean. If this works all the way through, you know, then like let's see if it works all the way through. Implement serializable. Okay, so now that's that. In order for that to work in GraalVM, I need to implement serialization. So class cat AOT processor, implement bean registration AOT processor. Okay, so this is a callback. So actually, this is just here. I want that to be a bean here. Bean static cat AOT processor. So this is a callback that gets run at compile time. And I'm just going to use this to prove that at some point I get a bean of type equals cat.class. So system got a bean at compile time of type cat.class. Okay, so let's make sure. Okay, so first things first, does this work? There's two different life cycles. I know it's confusing, friends. I don't mean to throw so much in your face. First things first is, remember, Spring has ingest. That's where we read XML at component scan, you know, at configuration plus at bean classes, all that stuff. It's registered during ingest, right? And then over here, you know, over here you've got all that stuff gets normalized. So normal, you know, bean definitions. So you get objects of type bean definition, you know, and they all are related to each other. So there's no, at this point, nobody cares about the configuration classes and the component scanning, all that stuff. All this stuff is gone. Spring doesn't, when the code starts running, you know, there's traces that this is how we got those beans, but ultimately they all turn into bean definitions and they're all normalized. So if I have a bean method in a configuration class and I have a bean defined in XML, all of them get turned into bean definition objects in the bean factory or the application context. And then finally, we have actual, you know, beans, you know, run. So we have beans, bean post processors get invoked. We get initializing bean, you know, application listeners, all that kind of stuff happens once we have the runtime, right? So the goal here is to make it so that, you know, we want to define the beans kind of here, right when the bean definition graph is being created. I want to define the beans containing the interfaces and have them visible here. But then to make things more interesting, there's also another phase called you know, compile time, AOT. And so I want to make sure that this also works at AOT. We can detect, well, it's a little complicated, isn't it? We have this at compile time, we do this whole thing again. We do ingest up to bean definitions. At compile time, we do not go past bean definitions though. So what I want to make sure is that this bean definition gets created at compile time, because then some code can come along and recognize that it's there and then contribute hints for GraalVM. Okay, so I guess let's just run it. Let's just see what we got. Oh, that didn't work at all. I cannot find a single main class from the following candidates. Application. Oh, declarative. I have another one. This is not my first attempt at this code. Let's just comment this out here for now. Okay. Run. Okay. So you can see very clearly it registered the cat and it called the constructor, and then once it called the constructors, our post processor over here, where's our post processor? Our post processing bean with bean name, whatever. So the constructor was called. We have a live object at the very end of the life cycle, and then we're able to see the cat type. Okay, so that means that our code worked earlier on, right? Like, let's go back here. See that? This is bean definition registry post processor. To make it simpler, let's just put them all in the same place. Okay, bean static. Okay. So get rid of this, rid of that. Okay. Okay. So now we've got this bean definition registry post processor, which gets invoked very early on, and then we have the bean post processor, which gets invoked very late, right after almost after everything except for the very, by this point, by the time we get access to the actual bean, there's all the bean definitions have been created and all the bean definitions have been turned into objects. And now all the constructors have been created and even all the setters have been created, but not any of the lifecycle methods. So this is like very late in the game. You can still change the object graph. You can't change the object graph, but you can change individual objects in the object graph. At this point, we want to change the object graph itself, right? So we want this to change the object graph to register beans for those interfaces. And then we want to prove that we got those beans by just printing them out. We're just tagging them here. Okay, not a big deal. And by the way, the contract is, that's the contract for that. And then separate from all that, we have a AOT processor. So bean static, where's my, do a AOT processor here. Keep things simple. Static bean registration. Okay. New bean registration AOT processor. Good. So now here, this code gets run at compile time, right? Only at compile time. So system out analyzing bean of type registered bean.get bean class.get name at compile time. Okay, and so we want to say if registered bean.get bean class, so is assignable from serializable.class. So it's the opposite of is instance of. Is registered bean.get bean class instance of serializable. So it's the opposite. Okay, this is something that Trustin Lee the other day taught me. So I say is assignable from this, right? So much nicer. Okay. Okay. Then system out found a bean of a bean that is serializable. Okay. Registered bean.get bean class. So lots of different lifecycle things that need to be correct. So if that's serializable, then we return a new AOT contribution. And we don't care about serialization. Obviously, that's not the end goal, but I just want to know that all the different things line up at the right time, right? And so this is just kind of a simple example to see that everything's clicking. So I'm going to register a type reference for a serializable type. That type is registered bean.get bean class. Hey, Abdullah, hello, how are you? Okay, what is the type here? So it is type reference of serializable. Okay, so type reference of dot get name. Okay, so yeah, good. So for those of you joining, we're just trying to I'm just trying to prototype something out. Nobody's asked me to do it. Oh, hey, thanks for that. That's very kind. I appreciate it. Welcome to the stream. Hello to the programmers in Uzbekistan. Well, actually, I'll just leave that up there for a second. That's very kind. Okay, thanks for joining us today. Well, let's see. So basically, okay, let's try this out. Ready? One more time. Hello, cat. Post-processing this. So I don't want to actually... let's see here. If if cat dot class dot is assignable from bean dot class, say if, okay, then bean dot get class dot get name. Okay, restart. Okay, so post-processing, yeah, we found this cat. Okay, we found this one. Yeah, it's working. Okay, now what about compile time? Let's try that. Okay, so we go here and GraalVM native compile. Found a bean. Oop, there it is. Analyzing bean of type this, right? Found a bean that is serializable cat class. Okay. Analyzing bean of type cat at compile time. Found a bean that is serializable demo class. Okay, so that worked, right? So that means that we should have here in the build directory generated AOT resources, serialization config. There's our type cat. Okay, so things are all lining up, right? We're getting the right life cycle. Now we have to do a little bit more. Now we have to have some way to automatically discover those interfaces. And instead of manually registering cat.class, we need to discover the interfaces, make sure that they're valid interfaces, and then register them. So that's the next trick, okay? We've got our first iteration. We've got all the things lining up. We're automatically able to see, you know, things are getting registered at the right time in the right way. They're being visible at compile time. So now we need to do it for like any old interface, not just cat.class. Yeah. AOT means ahead of time. So in Spring Boot 3, there's a new engine for GraalVM, native images, right? And the way this works is GraalVM hates dynamic things. It doesn't like JNI. It doesn't like the native image support in GraalVM. It doesn't like serialization. It doesn't like JDK proxies. It doesn't like reflection. It doesn't like resource loading from jar files, you know, like class path dot whatever. It doesn't like any of this kind of dynamic stuff. And so it'll fail. It can't turn your code into native code if you try to do these kinds of things, unless you tell it about it. You have to tell GraalVM about this stuff. And it'll make it work. It'll make it look like it works, which is also, you know, it's not exactly the same, but it's so good that most people don't care. It's the difference is not worth having a discussion about. And part of the reason that this stuff fails is because when GraalVM does its work, it starts the application, it starts compiling, and it looks at your main method, and it goes here to the run method, and it says, oh, okay, run is going to be using application.class and string arguments, and then it looks at run, and run also has configurable application context, and then configurable application context has application context, and then that has application message source, application event, you know, all these types, and it just keeps going and going and going until it has a whole graph of all the classes that you're using in your code, all the types that are very explicitly being used. The problem is it doesn't know about dynamic stuff. It can't see the serialization. It can't see the reflection because this is at compile time, not runtime. So there's no way to do the analysis on the code base at compile time to deterministically discover all this dynamic stuff that you might do. Like, for example, in Java, you might have a method somewhere where you do like, you know, var name of class equals java.lang, and then if math.random greater than 0.5, you know, name of class equals string, else name of class equals integer, right? Or something like that, right? So it just can't know. It doesn't know what these classes are going to be. And you might then take that class and do class.forName, name of class. Okay, var class, right? Well, so the compiler can't see that you're going to do this dynamic stuff, and so it doesn't know to keep these classes. Remember that graph I just described where it crawls all the types and looks at all the ones that are being used explicitly? It throws everything that is not in that graph away. And so stuff like this that you do at runtime will then fail because this maybe the integer type doesn't exist anymore. It wasn't kept in the explicit graph, right? So you need to provide configuration. And that configuration is like this, reflect config. Here I'm saying, hey, somebody told Spring somewhere, hey, somebody told GraalVM, hey, I'm going to use this type called client HTTP connector auto configuration. Don't delete it, okay? Or I'll use this type called server properties netty. Don't delete it. And I need to be able to access the constructor with no parameters and the method called set validate headers that takes a parameter type of Boolean, right? So that way the memory, the native image will have the data about this type, okay? So what we need to do is we need to provide that configuration. Well, it's painful to write this configuration files manually. And so Spring has a very nice AOT component model. And that's what this is. You can see here, I've got a AOT processor. During compilation, I get this callback. It gives me a reference to this thing called the registered bean. I can then get the class of the bean, right? Cat.class in this case. And I can then write out some hints. I can write out the serialization config.json here. I can add a hint for this bean class, and that will end up here in serialization config.json. And that way, and this is like infrastructure code. Most people don't need to write this kind of code. Clearly, right? I mean, I hope not, but it's there if you need to. Because if you're like a framework developer or an architect for your organization and you've got organizational standards, you want to put those organizational standards in a single place and then integrate them, right? And so you can do that with these AOT processors. It does replace a lot of reflection, right? Or at the very least, it makes it possible to do the reflection, right? So let's say the question here the comment is, it doesn't replace reflection, right? And it can, absolutely, right? You can do code generation as well, but for example, the simple thing is just to take the existing code that you've got and make it work. And if you know at runtime, if you know when you start your application that you've got a method that you're going to call, and that's going to do class.forName, and it's going to do reflection, it's going to do serialization, it's going to do all these things, then you need to make sure that there is an entry in this JSON config files, in these JSON config files. You can't make it, so you have to discover that, or you have to call, something has to provide that configuration. And one of the easiest way to do it is to use, there's like 4 callback interfaces you can use for different purposes in Spring, and most of them end with AOT processor. There's also one called runtime hints registrar that you can implement. But basically, in all the cases, you get access to something called runtime hints, right? And then with the runtime hints, you can say hints.serialization or proxies or reflection or resources or JNI. And then you can say, I want to register reflection support for a type called whatever. Maybe I'm going to reflect on Java-Lang string. And then what kind of reflection? Well, I want to do declared. I want to do field. I want to do introspection. Or I just want to do it all. I don't know yet. And just give me support for everything. So obviously, I don't need to do reflection right now. Now, I'm only so why does this matter for us? Because imagine this interface here, this HTTP Exchange interface. Spring will take this interface and turn it into an actual object. It'll create a proxy for it. And there's already declarative support for registering AOT hints JSON configuration for this. But I need to make sure that whatever we do right now to register these types in the Bean factory postprocessor makes the object visible during AOT in compile time so that the existing support automatically works. Okay, so that's the thing, is I'm just creating my own AOT processor just to make sure that I can see that type, but I don't really care about it right now. I just want to make sure that the existing support for AOT kicks in, right? It does the right thing. So if this doesn't see the thing, if this doesn't work, then the existing support for Spring won't work either. And we need to make sure that doesn't break, okay? So my goal is to delete this at the end This is just a proxy. We're just using this as a, like, if this still works, then the real one from Spring should still work. Okay, so now, next question. To do, discover all interfaces. Now, here, my friends, things get a little weird. I've got some existing code. I don't like it, but it works. So let's see what it does. Assuming it still works. This one. So I've got this get base packages method, and so already we've got something kind of interesting. Like the first problem is, how do we discover what package to start searching, right? This is super interesting to me. So the obvious one to me is auto configuration. Auto packages. Yeah, this one. This is a Spring Boot callback. Can I get the, no, already I've got a problem. How do I get the current packages, right? I need a reference to a bean factory. Okay, so I can get that bean factory down here, right? But which one runs first? String packages bean factory. Or what is var list of strings? So list of string packages found the following packages. Okay, good. Now system out registering bean definition for cat. Okay, so which one runs first? My hope is that this one runs first, then I can just save the reference to the bean factory, and then in this code I can register the beans. But somehow I doubt it. I think it's probably the other way around, so that might be a problem already. Let's just try it though, okay? Registering bean definition. See, that's a problem. Registering bean definition for cat. That's this right here. And then we get the packages here. Already we've got a problem. Okay, wait, let's put a breakpoint here and see what type our bean definition registry is. It's probably a bean factory. Maybe we can just downcast, you know? Registry. Yeah, default listable bean factory. Okay, good. So you know what? I'll do a little life hack here. Let's see if that works. So if registry instance of bean factory, then then what? Then we want to get the packages. So I can say list string base packages. Okay, equals new array list. Okay, and then we'll say configuration packages dot get bean factory base packages dot add all to that. Okay, how about that? What do you think of that? That kind of works. Can replaced. Okay, yes, but I want that visible. Does that work? Can I? No, I can't. So I need to lift that out of this base packages. Tyler got it wrong this time. The IDE got it wrong for the first time. There. So I want that. Now, system out. The base packages are base packages. Okay. So we don't care about this anymore. Oh, come on, Josh. So let's see. Hey, look at that. That worked. So I'm able to get the base packages earlier on. That's part of it. Okay, already we're good. So now what? Is that what we want? Why wouldn't that work? That seems like it would work, right? If we wrote the code to automatically discover all the interfaces in your Spring Boot package, right? My application's in package demo, so therefore I want everything underneath that. That seems like a reasonable thing. Okay, so that seems already useful. Okay, good. So we have the base packages. Now what? Okay, and then we can go here and say assert state base packages size greater than or equal to 1. There should be at least one package. Okay, that seems reasonable. We want to make sure that's true. Okay, now we've got all the interfaces. No, we've got the packages. Now we need to find the interfaces. Find packages. Find interfaces in packages. Now what? What's the next thing we can do here? So I have some existing code for this. Maybe we can reuse some of it, huh? And I'm trying to clean this up. I don't want to reproduce the same code. It has some issues, so I want to avoid recreating the same thing. Okay, so given that, we stream it, and then we go from each package and we build a scanner and find candidate. So I have this method that builds a scanner. Let's use that. Okay, that was pretty useful. And just match this here for now. And this scanner is going to need a reference to the environment. Does it? Yeah, it needs an environment. How do we give it the environment? Environment. Okay. And we need a type filter. So, what does this do? This class path scanning component provider how do we do this? We need to add an include filter. What can be a type filter that works correctly here? Oh, wow. Lots of type filters here. The annotation type filter, which matches classes with a given annotation, checking inherited annotations as well. Okay, get annotation. Okay. Okay, let's just use that then. This seems like it could work for us, right? Okay. So we need to provide a scanner. This method provides a scanner, but it needs a pointer. So let's just make this static. You can always tell what your dependencies are if you have a so type filter, okay. And then we need a resource loader. In order for this to work, we need those three things. And that's okay, because I want to think about that, right? We want to think about how we create that. So build scanner. We need the environment. Do I have the environment at this point? I don't know. Let me see. How would I get the environment? Does the Bean Factory have the environment? I do environment aware. Get environment. Nope, that won't work. What about if I do... Okay. There is a way to solve this problem, but it means my laziness. See, I'm lazy, and I've been trying to fit everything into this anonymous inline class. So static class, actually just class, my whatever. Implement. So we're going to call this register. Whatever. Whatever. Definer. Okay. Like I've got no good name here right now. I don't care. I'm just trying to get it all into the right place. So implement this. Implement those methods. Static, just to make sure I don't have any references to variables in scope yet. And then we have this method here called build scanner that will go here, private. And we have this method called post-process bean definition registry, and that goes here. Okay. And then we can remove this. We can say that this is a type of my bean, just definer. Okay. Return new definer. And then we can extract that out to a separate class, top level. A bit more clear. Okay, good. So we have this type now. This is the component scanner. Okay. So in order for we need to build the scanner, but in order to build it, we need a pointer now to the first thing is the environment. So there is an interface we can do, environment aware, right? Implement that, and we can just stash it. So private environment, this dot environment equals environment. But the thing is, I don't know if this gets called early enough. Set the environment. We need this method to be called before this gets called, and I don't know if that's going to happen, right? I don't know if that's even conceivable. We'll find out though. Okay, so let's try that. This dot environment. Okay, so assert not null. This dot environment. The environment must not be null. Okay. Okay, that's part one. What about type filter? We can come back to that later, but we need a resource loader. Okay, what about that? Well, resource loader aware. Same trick. So we go over to here, and we have an private resource loader. And that will be here. Okay. Set the resource loader. Okay. And good. Okay, so now the type filter. How do we want to discover this? I mean, right now, I guess we can use let's just cheat for now, just to make sure that this works, okay? So for now, again, we're just trying to make sure that all the parts work at the right times. We don't care about the implementation of the details yet. So we want to say, hey, does this type just find anything with that? So new annotation type filter dot class. Okay, good. Now what? Does that work? Assert dot state. I don't know. Whatever. Does that work? R scanner. Class path components. Wow, that's so long. Okay, now. How do we know if it worked? We say scanner dot find component candidate. Okay, there we go. Base packages dot. So for for string base package in base packages, and we say scanner dot find component base package. And what does that give us? That gives us a set of bean definitions. These are candidates. These are not like actual bean definitions yet, and we can do with them as we like. So I can then do for bean definition bd candidate components, and then I can say bd.get bean class name and print it out. Found this. So if everything has gone correctly, this should only run one time, right? Because we've only got one thing that we consider to be worthy, and that's this. Okay. I mean, this assumes the resource loader and the environment are also not null. Okay, wow. That got a lot further than I thought it would. It failed because it's there's something already running, but we'll just stop that. Okay, good. So it actually tried to start up. Let's build that, and then run this again. Wait, what? I don't understand. So it set the resource loader. And so these are all working. Look at that. It actually got to this point. The resource loader and the environment are also both not null at that point. That's great. That's good to know. That was lucky too, by the way. Like, I had no idea that would work. That means that these types are more fundamental. They're present from the very beginning of the Spring initialization, right? Okay. So now what? Why is it giving me? I feel like we've got a bit of an issue because it's giving me types that clearly, aren't suitable. Is it using the filter? I don't feel like it is. Scanner, build scanner. So we've got this type filter. Is it actually applying it? Add include filter. Add, is there like an exclude filter? Is it, so new negating, like new type filter. Okay, so let's just use our existing one, type filter dot match metadata reader, metadata factory. Okay, we can say that matches. No. Right, I want to exclude everything that doesn't match that. Right, that seems reasonable, doesn't it? So, because maybe it's including a lot of stuff anyway. I don't want to do that. Nope, that didn't work at all. Also, why is it running the wrong Spring Boot application? Let's get rid of all this. Get rid of all that. And that's in demo. Good. Get rid of that. Get rid of this. Hit apply. Hit OK. Run. Yeah, okay. So it's doing something that I'm not quite understanding, which is it's finding everything. I thought the filter would exclude those other things. We don't want it to find everything. We just want it to find the things that have that annotation. So for those of you just joining, I am trying to make it so that when you have an interface like this, it automatically gets turned into an actual bean, right? Spring has a new mechanism in Spring Framework 6 to, if you write code to explicitly create it, where's an example, then it'll work. But basically, I want to make it so that you can just write the interface, right? I don't want you to have to use any factory methods at all, and any, you don't have to create a bean, right? Just create the interface, let it sit there, and Spring will take care of the rest. I want that to happen, but I'm trying to build it, and we're trying to write some very early, infrastructure code to discover the types and then register them. Okay, so is candidate component. What does this mean? Bean definition, get metadata is independent. So what does independent mean? Determine whether the underlying ID. Oh, it has to be a top level class. Oh, okay. Yeah, that's fair, right? If the type is like class foo and is part of another class, then I can't create an instance of foo unless I also have a reference to the parent, right? The outer class. Okay, happy developer. Great question. Friend. I wrote a book. Okay. I wrote a book. And I want you all, it's free. That's how much I want you all to read it. It's just a free little white paper. I mean, it doesn't cost any money. You have to put in some information. So I guess it's not 100% free, but it's not hard. Like most Starbucks want almost as much information to get into their Wi-Fi, email, first name, last name, job title, country. That's it. Then you can download it. It's 50 pages. It's free. If you don't want to give us that information and you don't like to read or you don't like to read, fine. Either way, I'm with you 100%. I did a video. And this is also free. It's just a Spring Tips video on YouTube. And you don't have to put any information. You just go to YouTube and watch. And then give it a thumbs up and a like, please. And I did it myself. It's 2 hours. Incredible details, animations, graphics, live coding. 2 hours. It's a deep dive masterclass on all things AOT. And so you can get that here as well. Okay. This is all about AOT. And by the way, for those of you just joining, in about 20 minutes, I have to leave because I have to go to SpringOne Tour Korea, where I speak in 2 hours. So if you're in Korea, join me. You can still register, I think, probably. I have no idea. Okay, so back to this, huh? So we're trying to determine why this filter is not. So this is saying, is the type independent? Is it a top level type? Okay, this is true. Our interface is top level, and it doesn't require a reference to the outer type to create a new instance of it. That's fair. And then the other thing is so we don't care about types that are annotations, right? So interfaces are fine, and classes are fine. I guess enums. I guess we don't want enum metadata reader dot get class metadata is, I don't know, abstract. We probably don't want abstract things. Well, actually, I don't know if we do it. You know what? Because that would get rid of the interfaces. Hey, no problem. I hope you. Thank you. I hope you read it. I hope that helps. This is please read the book. It's quick and easy, and it's free. I want you to learn. This is really powerful. We don't even have time to cover all the power, right? It's just so crazy good what you can do in the AOT engine now. You can do code generation. You can actually write Java code out that gets fed into the GraalVM compiler, or you can run the code generated for you by Spring in the JRE. It doesn't even have to be for GraalVM. You can do it on the JRE, and you get 10-15% less memory and less startup time and all that stuff. Even that is pretty worth doing, right? But especially for GraalVM. Okay, anyway, moving on. So we've got this annotation components provider, and I want to, why is this? I want to say remove, reset filters. Use default. Okay, what are the default filters? What are the register default filters? This is, we don't want that. We don't want, so I'm going to do a reset, and I'm going to say don't include their default Spring filters, Spring beans. We just want interfaces. So, okay, good. That might help. And then we add this include filter. Okay, now we're cooking. We might have a solution here. Nope, no solution. Oh. Okay, reset filters. So tell it not to. So why is it finding all these things? Okay. Build this, close that out. Well, I think it should be false, right? the reset filters is saying true or false. Should I use the default filters? I don't want it to do any. I want to reset it, and I don't want it to. If you look at the method, it clears the filters, and then it reinstalls the default ones if this is true. Well, I don't want it to reinstall anything. I want it to be empty, and then I want to add my own filter. And that filter is just to find things that have that annotation on it, right? Find interfaces. So why is it doing that? I mean, it's not the end of the world if that doesn't work. And the reason is because, well, first of all, it's already doing, it's giving us too much, but we can always filter that ourselves manually at that point, right? Like, it's not really a big deal if we have to do that ourselves. It would just be nice if that worked, right? Wouldn't it? So find candidate components. What does this do? So find base package. So what am I doing? When I create that scanner, what does that do? I'm saying add this include. So let me just put a breakpoint here. Let's just see what filters we have, because I'm actually confused as to why it's still working. It's just more of a, even if I know how to solve it, it's just the principle of the thing, isn't it? So exclude filters is 0, and include filters is 1. And that's this one. Okay. Okay, which takes precedent, right? Like, so let's see here. Add exclude filter, new type filter, return false, match nothing, and then I'll add 1. Does that work? Like, no, that doesn't work at all. It's just too darn good. Is it using the index? Maybe that's what the issue is. Like, I don't want it to use the index. So let's just see if that does it. Like, if I have no matches, I should get 0 beans, right? Nope, still kicking in. That's bizarre. I wonder what scanner.after property set. Scanner dot clear cache. And then, okay, let's try this. Annotation filter. What does this do? This looks for, it matches classes. Okay, it checks. So the annotation type, consider meta annotations. What does HTTP exchange do then? Mapping. Oh, wow. Wow. I've been using Spring for decades, and I don't think I ever knew about this type. Wow, this might actually be the key to making this generic. We should keep this later. Okay, wait, who uses this? So request mapping. What about, okay, what if I go to my build, Spring boot starter rsocket, right? Command-Shift-I, download all the internet. That is neat. Mapping. Okay. Find usages. rsocket destination mapping, isn't it? Message mapping, that's right. Does this have mapping? Message mapping. Oh, that's bizarre. Why doesn't this have @mapping on it? Yeah, this is for rsocket. Why doesn't this? Interesting. Okay, whatever. Moving on. We don't care about that. That turned out to be a dead end. So ignore that for now. It's kind of interesting that that type exists. That would help us find all the HTTP ones, though. Okay, do we care? I mean, I don't really care, actually. It still works fine. It's giving me too many types, but that's okay. I have to like scanner.add include filter, type filter. And then what does the type filter that I'm providing do? The type filter I'm using is this one, new annotation type filter. Okay. So So I don't actually care if it gives me too much because we can still just whittle it down, right? We have the ability to inspect the class at this point. And it's there that I want to look for, the actual predicates, right? We're not actually obligated to do anything with these types. They're not registered yet. So then what? So then we do a test, right? Oh, I got to go in 10 minutes. Okay, let's see here. How do we test? What kind of test do we want to do? We want to say, is candidate, right? So private Boolean is candidate, bean definition, return false for now. And we'll say, okay, for each of these, this is where I can't help myself. Base packages dot filter. Yeah, okay, filter. No, flat map. So BP scanner dot find that. Okay. Dot flat map. Okay. Dot flat map, and now I've got a set of bean definitions. No. But for each, so map, flat map, okay. BP, scanner.find component candidates, BP. We want to turn this collection into a stream, stream.of, okay. So we can flat map it. And then we want to do why is this giving me a stream of sets? I don't want that. I want a stream of iterables from I'm so dumb sometimes. But stream, okay, and then from there, do a flat map as well. I'm given a bean definition. I'm not going to return. I'm just going to do a map. Okay. So given the bean definition, I'm going to filter it, right? So given a bean definition, we say is candidate bean definition. And then finally, each one of those, bean definition, we want to register the actual thing as a type. Okay, so and then so we can get rid of that logic, and then we do a register. So register private void register bean definition for interface. Okay, that's contract bean definition BE, and then we'll say register bean register definition. Okay. So that should work, right? Good. So now we don't need this code. If everything works, and we don't know if it's going to work yet, but if everything works, then this will automatically get done if we correctly flesh out these methods. Okay. So let's try it. Okay, let's do this. So now what? We're going to say is candidate. How do we know if it's a candidate? Well, we say, okay, get the class. Bean definition, get bean class. Ooh. We don't have a class reference. You know what I just realized? This might break if somebody wants to use the explicit registration. So that's another thing we have to think about. Like if you want to use @bean and you want to return the interface and you want to call HTTP service proxy factory and do all that stuff manually, then it's not going to be welcome. You're not going to like that this code comes along and automatically tries to turn your interface into a bean, because you might want to control how that bean gets registered. So we need some way to disqualify that. And we could have like maybe a Spring Boot switch or an annotation or something. I guess that's okay. So yeah, next to do, make sure not to register interfaces that people plan to manually register. Okay, so now bean definition get bean class. Okay, var bean class name equals this. System out bean class name is can we do this? I don't know. This feels icky. I'm not sure if we're allowed to do that at this early stage, you know? So throws exception. Return is candidate F. Okay. So I really need to just create a logger, but whatever. I'm too lazy right now. And I'm also in a hurry. I'd rather keep this filtering logic in here. So return is candidate, return false. Okay, we want to assume it's not a candidate unless it's actively coming back as true. Okay, so then what about this? Going to register bean definition dot get bean class as a HTTP service proxy factory declarative client. Let's just see if that works. Like we're already pretty close to this. Nope, that didn't work. Oh, we don't, okay, wait, we didn't actually do the test, did we? Okay, so return, and okay, merged annotations, oh dear, okay, merged annotations dot search equals merged annotations dot from mapping exchange HTTP exchange.class, right? Or is it search? Search strategy dot type hierarchy. Okay. Search dot from. Now we're searching for those annotations on this type. Merged annotations is present. Shoot, what is this supposed to be? What is this? Annotated element. What do I do this? Do I use this elsewhere? There we go. Merged annotations from class get qualifier. Aha. From class get qualifier. So merged annotations from class, a class, get HTTP exchange.class. Okay. Dot is present. So present. That's what we're trying to do. Okay, whoops, there's no way that'll work. Return this, get rid of that, return this. Look at that. So this is very specific to HTTP. We need to do something for our socket, but you know, we can stub this out. This is a strategy pattern, right? We can actually extract out these two different things as callback interfaces that get injected. So that way, when we implement this for HTTP, it'll work for HTTP. When we do it for our socket, it'll work for our socket. We just change out the annotations and the validation logic, the matching logic. But the core heart of the algorithm is working. So basically, now, this is going to match, okay? So, and then it's going to go to here, and here, you know, we can just actually create the bean method, right? Let's try it. Let's just do, I've got to go. Bean class, class dot for name, bean class name. Okay. And then we say, same thing here. I'm going to do throws exception. And then we say, register bean definition X catch exception E system out. Whoops. E to get message. Okay, so there's this. So now we need to create the bean definition quickly. So we need a bean definition registry to do that. So we can pass this bean definition registry. Pass that in. Now we go down here, we say registry.register bean definition builder dot generic bean definition with a class. No, with oh, we gotta, okay. So I'll have to wait. Friends, I gotta go. This is good. You can see what we need to do though, right? This is pretty straightforward from here. I need to create a supplier that uses that class and injects the current web client and registers the bean definition. And I think we're close. You can see it's correctly identifying just this one type, and all of the types in the Spring Boot auto configuration path and in my code, only this one type should be registered as an HTTP service proxy factory. So we're doing good. There's a lot of, obviously this is like, there's a lot, right? Bean class name is, okay, Spring, use var, but I know the Spring team uses the actual fully qualified type, so I'm having to like catch myself. All right. Thank you, everybody. I hope you got something out of it. Come to SpringOne Tour Seoul in a couple hours. See you there if you're coming. Thanks for your time. Have a great day. Bye, everybody.